start. And, oh, I guess we're still waiting on PowerPoint. That's all right. It will open eventually. Slowly but surely. Okay. So today's loops. Yay. This is the last piece of the puzzle. We now know how to make programs that go in a straight line, that branch off. The last piece is to make programs that do this. Come back around on themselves. Won't that be fun? So let's make that happen. All right, let me motivate loops for you. I think I've already motivated them for you in the example from the Guess the Number game that we did last time. That will definitely be nice to have a loop there. But yeah, let's keep on talking about that. So we've been copying and pasting a lot of code, right? Especially that Guess the Number game. And that's silly. We want to make programs that come back around on themselves, to revisit and rerun code until we ask them to stop. So our programs, they can do this. They can go straight line versions of themselves. They can branch off, do other things for a while. They don't have to do the same amount of things. This one can do more. And then they can come back together and then do more straight line code, ... The last piece of the puzzle is to do that, to do the branching, straight line code, come back around, as well as loop. Okay? That is the goal. That is where we're going. So, yeah, our programs are currently combinations of straight lines and branches. Now we want to loop. We want to add those loops in. Okay? So let me teach you the simplest loop first, and then I'll show you a fancier one as well. Okay? So let's see here. Yeah, this is called a while loop. It looks very similar to an if statement, right? It's got a word, it's got some parentheses, and inside of it goes a Boolean expression, and then inside of that we have the body, and that's the stuff that keeps getting executed. So here's the execution diagram for a while loop. It's kind of cool. The very first thing it does when it comes into itself is checks its Boolean expression. That's either true or false. If it's true, it runs the body and then goes back to check the condition again. See that? If it's false, then it's done with the loop. It is complete. Okay? It does the rest of the code at that point. So this body, we say, is repeated while, that's why it's a while loop, it's repeated while the expression gives back true. Okay? So I have an example for us. Let's sum all the numbers from 1 to 10. Boop, boop, boop. We're lecture 6 today. Oops. And let's make that while loop. So sum all the numbers from 1 to 10. Let's actually print them first. Print the numbers from 1 to 10, then we'll sum them second. I just want to print out 1, 2, 3, 4, 5, all the way to 10. That's all. 1 to 10.cpp, I guess. Here is an example of a while loop. So I need code in the body of my while loop to do the same thing every time, right? I need to write the same code because it's going to get repeated, but I want it to do a different thing every time it gets run. So the idea is I want to output the value of a variable, for reasons we call it I, and then like I will be 1 the first time we hit the body of the loop, so I can start I at 1. And then because I wanted to print 2 next time, maybe I can say I++. Yeah? Because then the next time it comes and it repeats this, I will be 2, and it makes it 3, then it'll come back, print 3, make I 4, and so on and so forth. And so the condition here is I want to keep printing while I is starting at 1, while I is less than or equal to 10. It's kind of like English. Did you catch that? So that's going to work. Whee, and there it goes. So that printed all the numbers from 1 to 10. Okay? So this was start I at 1. This was continue. Always do the body while I is less than or equal to 10. I want I to range between 1 and 10. So we're going to print I, and then increment I. So this same code getting repeated does the printing from 1 to 10. Isn't that neat? That's so beautiful. That's much better than saying, like, copying and pasting this code 10 times. That's essentially the equivalent, right? That's no fun. We'd much rather do it this way. Okay? Are there any questions about this? This is new. Print from 1 to 10. So I'd like to draw what's going on for you as well. So let's copy and paste. Boop. I don't know. I'll put it over here. Just in case this is still a little confusing, let me show you exactly why it's going to do this. So we have I starts out at 1. Then we check, because we always run the condition first. Condition, if it's true, do the body, do the body, do the body, as long as it's true until it becomes false. I starts at 1. Is 1 less than or equal to 10? Sure. So we'll do the body. We will see out I and do I++. So we print 1. I++ makes I2. Come back. After the body is complete, we always come back to the condition again. Is 2 now less than or equal to 10? Yeah, it is. So I will print the 2, make I3, I++. See how that's working? Come back around, 3 is less than or equal to 10. Print the 3, I++. Dot, 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 until I is 9. Print the 9, I++, because 9 is less than 10. We do the body still. Less than or equal to 10. So now I is 10. 10 is less than or equal to 10. True. Do the body once more. Print 10, make I 11. Now we come back to the condition, and it's finally false. Is 11 less than or equal to 10? No. Answer is no. False. We're done with our loop. Okay? So if I were to print I after this loop is finished, it would be 11. That's what stops the loop. Does that make sense? Are there any questions about that? These are all new concepts today. Because now I want to do a similar yet different version of the same program. I'd like to make a loop that sums the numbers from 1 to 10. Okay? I'll loop using a j variable, maybe. Here's the strategy for that. If I want to sum all the numbers from 1 to 10, I will again use a loop to range over those numbers. Maybe I'll do like, instead of I, I'll use j starting at 1. And then the trick for that is to have a separate variable to hold the final answer called sum, something like that. And you start it off with nothing. You start off with 0, and the trick is you keep repeatedly adding in the current value of your variable. So it's going to range between 1 and 10. Add that into sum all those times, and then it will hold the sum of all the numbers between 1 and 10. Right? So j starts out being 1, add j into sum. Now sum is 1. Make j 2. Now add j again into sum. Now sum is 3, right? It was what it used to be plus the 2 now. Increment j. Add it into sum. Sum is equal to what it used to be, 3 plus the 3 of j. Now it's 6. And eventually it'll hit, I think it's 55 is the final answer. Once we get to 10, 9, 10. And then we'll stop the loop when j gets to be 11 because we don't want to add 11 into our sum. Okay? So hopefully with me saying this in words enough times, it will make more sense. Okay, so here is some separation. And then int j equals 1, int sum equals 0. Okay, start the sum out with 0 so I can repeatedly add j into sum 10 times and increment j each time. That will allow j to range over 1 and 10. While j is less than or equal to 10, do stuff, and then j++. So do we see how this code is going to allow j to range between 1, 2, 3, 4, 5, all the way to 10. We will be in this body where when j is 1, 2, 3, all the way to 10. Once j becomes 11, it will stop the loop, and we won't execute the body. Okay? So every time I add into sum equals sum plus j, I'm adding that 1 into sum. I'm adding 2 into sum. I'm adding 3 into sum because j keeps changing. Okay? So adds 1 the first time, 2 the second time, 3 the third time. That's following along with this idea that I was talking about here. Okay? That's the idea. So let's watch it run. Let's see if it gets the right answer. Oh, I need to print the sum as well. See how it's sum. That would be useful. And it's 55. That is the sum of all the numbers between 1 and 10. Okay? And you can change this to 100 to get all the sum of all the numbers between 1 and 100. Whatever you'd like. As much as you would like to have that execute, you can control it. Okay? Any questions about this code? So, with that in mind, here's the original code. This is the same, copied again, I guess. No real difference. I have a question for you. Take this code, change it so that it doesn't print 1 to 10 anymore. Change it so that it prints 10 to 0 by 2. 10, 8, 6, 4, 2, 0. What would you need to change? So please get into groups, say hello to each other, help each other get this to print this new way. Okay? Decreasing order this time. I'll give you like, I don't know, 4 minutes to try this. It's going to have to type some stuff out if you want to. And please yell at me if you have any questions. I accidentally pressed the thing. Sorry. What do we think? Take another 2 minutes to try this. "15 more seconds and my alarm will make noise." All right. What needs to change? We want to print 10 first. What does that mean I should start out as?
10.
Yeah. Because that's the very first line of this loop. This better be 10, right? If that's the first thing we need to print. So that needs to change. Just draw a box around it. What else needs to change?
The plus sign that I plus should be minus.
Yeah, if you want it to go from 10 to 8 to 6, how do you decrease it by 2 at a time?
That is like, all right, yeah.
That needs to change. Yeah, something like that. That'll work. What else needs to change, if anything? There you go. Yeah, you want this to stop when you want this to continue while the condition is true and stop the second it's false. So when do we want this to stop? It's going to be whenever this gets smaller than 0, right? Kind of thing. So we want it to continue printing as long as I is greater than or equal to 0. Something like that. Because otherwise, this will never stop. It'll always be true. So let's watch that happen. Let me copy all this code. And because I've already declared I up here, I'm just going to say I equals 1. It already exists. Okay? I equals 10. So I equals I minus 2. And we want this to keep printing as long as, like 10 to 8 to 2, 6 to 4 to 2 to 0. We don't want it to get to negative 2, so we only want to keep printing as long as while I is greater than or equal to 0. Okay? Does that make sense? It's always a condition involving your stopping value, usually. Like, stay bigger than or equal to my stopping value if you're going downwards. Just like it's stay less than or equal to my stopping value if you're moving upwards. Okay, so this will work. Well, let's watch it happen. There it goes. 10, 8, 6, 4, 2, 0. That was this code right here. Are there any questions about why it did that? I guess I don't need this trailing new line. But that's a while loop. What questions do we have about it? It's a weird one. It kind of makes sense that while this is true, do all these things and repeatedly keep coming back. Hopefully you're getting used to this kind of syntax again, but when in doubt, go back to this execution diagram. It's always expression. If it's true to the body, go back to the expression. Repeat, repeat, repeat. Until it's false, then we're done with the while loop. Okay? And it's just while by itself. There's no like while else or something. That would be a little weird. Though that does exist in Python, which is disgusting. We don't need to get into that. But yeah, that was you changing some code that I wrote. Are we good to keep going? All right, so next step, I just want to congratulate you right now because, like, you should pat yourself on the back. This is a huge moment in this class in your computer science career. So I'm sure you've heard of the name Alan Turing before, hopefully. Look him up if you haven't. He invented what's called the Turing machine, among other things. And that is a model of computation that just describes what a computer can compute, any computer, ever. So it describes how every computer program ever made or ever will be made can execute. Any one of those can be modeled by a Turing machine. It might be a bit slow, but it'll get the job done. So it's a very nice mathematical thing that you can use to prove properties of programs, talk about what it means to be computable. Super cool. And so what I want to tell you right now is that our knowledge of C++ right now, after loops, lets us simulate any Turing machine. Okay? Therefore, we can write any program that will ever exist or has ever existed. Isn't that cool? It might be very slow and might be hard to write and long, but you can do it. You have all the computational tools now at your fingertips to write any program ever, to compute anything computable. That's awesome. So you might be asking, like, why don't we just stop the class now and just, that's the semester? I think as you read your book and do the labs, I think you understand that practice makes perfect, probably. And also there's some cool, nice things that we haven't learned how to do yet that will make our lives so much easier as programmers. Like, how about we make things outside of the main function? How about we make our own functions? Things like that. Those are technically not necessary to create anything computable, but definitely make you a bit happier as you write your programs, I would say. Okay? So, yeah. You can now simulate a Turing machine. You can create anything computable. You can compute any computation. Good for you. All right. So let's get into issues now, because with great power comes great responsibility. So your programs can go wrong in new ways now that we have loops. So a new kind of bug is possible. Your programs can end up running forever because they can stay executing the body, and that condition never becomes false. That's no fun. The easiest example of that is to say, while true. That's definitely a Boolean expression that never evaluates to false, right? So this loop will run its body forever. It will never end. The program will never end. Okay? So if you have a program that does not stop, and you would like it to stop, on the terminal, you can press Control-C, okay, while it's running. And you press Control-C, and it will stop that program, okay? So let me show you a nice example, kind of like this one. If we kind of messed up the condition here, we would get an infinite loop. So let me show that to you. Infinite loop.cvp. And I'll take this one. Boop. And I needs to exist again, so int I. Let's see what else. So I'm going to make this incorrect. So let's say, let's do the printing from 1 to 10. That's easier. So print from 1 to 10, it was supposed to be I is less than or equal to 10, right? What if we did something silly, like keep printing as long as I is greater than or equal to 1, and I starts at 1, and it's only going to get bigger. So this would be what I will tell you right now to be an infinite loop. Once we get to CSCI 45, you will learn that this is technically not an infinite loop. It will stop eventually. But I want you to think of it as an infinite loop right now. Okay. Are you ready? So it's going to print, all right? While I is greater than 1, I starts at 1. Hey, it's true the first time. Print 1, make it 2. 2 is greater than 1. Print 2, make it 3. 3 is greater than 1. It will always be greater than 1. Drum roll, please. Whee! There it goes. And if you have a runaway program, remember Control-C. Gets you back to the terminal. Stops the program. Okay? So that's a fun little infinite loop. Any questions about that? The new kind of error, a program that never stops. And you can also now understand the joke behind Apple's original headquarters. It was so large, they made their own street name, and it was they called their street name Infinite Loop. And their headquarters is number 1. 1 infinite loop. So that's fun. All right, I have some more examples for us now. Are we happy with while loops? I'm going to do some more programs with them now. Let's do the greatest common divisor algorithm. This is like the first thing everybody learns when they learn loops. It's a cool mathematical concept. This is arguably the first algorithm ever invented by Euclid in the BC era. And here is the algorithm to find the greatest common divisor of 2 numbers. First of all, let's just remember what the greatest common divisor is, if it's been a while for us. So the idea is you have 2 numbers and you want to figure out their greatest common divisor, the biggest thing that goes into both of them. So you create prime factorizations of both, and then you just circle what they have in common, as many things as possible. So it looks like 12 and 18, if I want the greatest common divisor, the GCD of 12 and 18, it looks like they have a 2 in common and a 3 in common, and that's as much as you can do. The rest don't match, and so that means that 6 is the greatest common divisor of 12 and 18. It's the biggest number that divides into both of them. Okay? Does that make sense? It's a very useful thing to be able to calculate for a lot of mathematical things. And now you know how, at least on paper. There is a very fast algorithm to compute this very quickly with using the modulus operator, in fact. Taking remainders allows you to converge at the greatest common divisor of 2 very large numbers very quickly. So let me show that to you. So here's the algorithm. I'm just going to spell it out in bullet form. So you have your 2 numbers, call those A and B. A and B are the 2 numbers you want to take the GCD of. And then here's the process. You repeat this while B is not equal to 0. What you do is you replace B with the remainder from dividing A by B. So while B is not equal to 0, so while B not equal to 0, that will be your condition. Replace B with the remainder from dividing A by B. So that is B equals, right, A mod B. That's your line. And then finally, inside the loop, replace A with the previous value of B before you took the remainder. So you kind of had to save it before you ran this line. So A is the old B. Something like that. Okay? So that will be our loop condition and loop body. And eventually this process causes B to get smaller and smaller each time, very quickly. And eventually B will become 0. And the second B is 0. A, that variable, now holds the greatest common divisor of the 2 original numbers. So you'll have to wait until CSCI 26 to learn the proof as to why that is correct. But this is the algorithm, at least. Let's do it. GCD.cvp. Let's ask the user for both numbers, A and B. Cout. Enter. I don't know. Enter 2 numbers. We can get 2 numbers at once with cin by doing this. I can say, just like I can print multiple things to cout, I can get multiple things from cin at once. They just need to be like space separated. And I'll show you how you can type that in and get them both at once. So that's nice. So now I have both of them. Now let's do the GCD algorithm on them. So here's the process. While B is not equal to 0, do the following. We need to replace b with the remainder from dividing a by b. So b equals a mod b. And then a needs to be equal to, we need to replace a with the old value of b before we took the remainder and updated it. So like a equals old b, and we better save that up here. And old b equals the current value of b before I take this remainder and replace it. So that's the ordering. Does that make sense? I knew that old value before I changed it, and so I just saved it up here. Okay, so the order really matters there. And then eventually this is going to cause b to become 0, and that means a holds the answer. The GCD is, and then print a. Boop. Enter two numbers, 12 and 16. GCD is that the original? No, yeah. GCD of 12 and 16 is 4. And here's how you can get multiple things at once. You just space separate them, and then press enter, and CN gets a both, which is really nice. 12 and 18 were the original numbers, right? GCD is 6. Cool. It's doing it right. And this works for any two numbers, like boop, 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 and boop. With my luck, one of those was like prime or something, so yeah, these are relatively prime to each other. I don't know, 128 and 1024. The GCD is 128, because that divides into it. So yeah, that is how you calculate the greatest common divisor of two numbers. I don't have any other good examples. 42 and what? 22. GCD is just 2. Any questions about that? Just following the algorithm. Just these keep getting repeated in this process until b gets to 0. You don't have to understand it, just we're practicing loops. All right. Are we ready to fix our guess the number game from last time? Make it perfect. Because what we really wanted to do was this. While the user's guess is not equal to the number, that secret number that we thought of, and we're hiding from them, then we want to ask the user for a new guess and check it and tell them if they got it too high, too low, or just right. And then we come back to this condition. If they got it right, it will stop the loop because guess is the number now. False. Not equals is false. But if they kept getting it wrong, it would repeatedly keep asking them. So it would never stop the program if they kept guessing 1 and it wasn't 1. Yeah? That's what we really wanted. So let's make that happen. Let's fix our guess the number game from last time. So I'll copy in lecture 5's guess the number program, and we're going to edit it. So here was the thing. It was this like amount of code that got repeated forever. So I'm going to delete the rest of it now. So we only need it once. We just need it inside of a loop body. Isn't that neat? We just need to do this. Repeatedly ask the user for a guess and see if it was correct. So while guess is not equal to the number, I guess we call it n here, ask them for a new guess and check it. Boop. And then I need to close off the loop. Did I do that right? Yeah, there it is. That's quite nice. You only need one line now. So if they guess 42 and the answer is really 50, it's going to say too low, guess higher. And then it'll come back around, still not equal, ask them for a new guess. Isn't that nice? So the issue now is initialization. So we want to plop ourselves into this while loop the very first time as well. We want to make sure that whatever the guess variable is set to before the user gets a chance to type their own guess for the first time, we better make sure that that value is not equal to n. So what is guess right now before we hit the while loop? Can anyone tell me? Do you remember? Right after line 10, what is guess set to? Not 0, but it could be 0. It's not 1, but it could be 1. What am I implying? Yeah, it's set to who knows what. It's random. It is undefined. This is just whatever was in memory at the time this program got loaded, because it's been declared but not initialized. Okay, so I would like to guarantee we hit the body of the while loop once so that the user can type a single guess. Maybe they get it right the first time, but we need to give them that opportunity, because there is a small chance, small but there, a small chance that the random value of the guess variable is equal to the number. It could be. And that will cause it to skip this loop and immediately stop the program, and the user will get very confused. So, in that case, let's set guess to be a number that is guaranteed to not ever be the number the first time. How about 101? How about -1? Something that's not between this range. Does that make sense? Because then we are guaranteed for this to be true. Guess is totally not equal to n the first time. We'll ask the user for one guess, and then we're off. Okay, that's pretty nice. And then also, we don't need to exit anymore, because the second the user gets it right, guess is equal to n, right? Which makes this condition false, which stops the loop. Now we're out here, and the program ends itself. There's nothing below it. There's no need to stop the program inside of the loop. It'll just stop the loop, and that's the end of the program anyway. Okay, so this is the relevant code that's very important here. Are there any questions about it? Because it will do the right thing. I want us to be very on the same page about why it's going to do the right thing. So, enter your guess, because guess is currently set to -1, and n is some random number between 1 and 100. It's totally not equal to n yet, so enter your guess. 50, too high, 25, too low, 35, 45, 40, 42, 41. You got it. And so the second it's equal, right, you print you got it, and then you come back to the condition of the loop, see if we need to do it again. But guess is equal to n now. 41 is equal to 41. So the not equals check is false, which stops the loop. We're done with it. Return 0. Isn't that beautiful? That's so much cleaner than last time, right? Do you have any questions about this program before I move on to a different kind of loop? All right, let's do it. So here is a different kind of loop. It's called a for loop. All right. I do want to say right now, if for loops make you uneasy, and they are a little weird looking to start out with, I know, any for loop can be written as a while loop, and vice versa, actually. They're both equivalent in computational power. That's why after while loops we had Turing completeness. But I think you will eventually grow to love for loops. You'll prefer them in certain situations, and I certainly do. Okay, so a for loop is just shorthand for a special kind of while loop. And I'll show you that. Let's see, what do I want? Yeah. Here is what a for loop looks like. It's got stuff before and after, but this is the loop itself. And here is what happens when you run a for loop. There are 3 pieces inside the parentheses, and they are separated by semicolons, which is weird. Okay, you have what's called the initialization, semicolon, then a condition, semicolon, and then an increment, a little statement there that usually does incrementation. There's not a semicolon to end that one, even though it would be a legitimate line of code otherwise. You don't put a semicolon at the end, as you might think you might have to. So they're just separators, and then you have your body, okay? So let me show you how this works. So when you run this for loop, what it does is, you run all the stuff before, of course, and then once you hit the loop, you first run this line, the initialization line, in it, and you never run it again. It just does initialization for the loop. Then it's kind of like a while loop at that point. You run your condition. If the condition is true, you hit the body, And then you don't come straight back to the condition like you do with the while loop. You also run, after the body is complete, the increment part up here, which is in a weird place. Body, then ink, in that order. Then you come back to the condition. Do you see that? You see how to read the diagram? As long as the condition is true, you do the body, then the increment. Repeatedly. Body, increment. Body, increment. As long as that condition is true. And you keep coming back to check. The second the condition is false is when the loop is over. Okay? That's the idea. So, obviously, this could have been a while loop. You just init as a normal line of code outside of the loop. You put the increment statement inside the body of the normal while loop. This can just be one big body. And then it's a while loop, essentially. Okay? So I'll show you the difference. So let's do 1 to 10 printing again. 1 to 10, 4.cpp. So again, here was the while loop for this. That was this one, and I'll copy and paste it in. So this was the while loop. And let me show you how to make this a for loop. I'll comment it out. So we just have the code itself. So to make this into a for loop, we just put the stuff in the right spot. We just say, all right, what's the initialization of this loop? Well, it's, all right, 4. We need to initialize I at 1. So you put this line as the initialization of your for loop. 4 int I equals 1, semicolon. And then what's the condition? It's still the same as the while loop, because it's for initialization, condition, increment. Okay? 4 int I equals 1, I is less than or equal to 10, and then there's an increment statement, and we'll get to that. And then you have the body of your loop. So here is the body of the while loop. I'll paste that in. But notice that we always, at the end of the loop, increment I. The for loop gave us a spot for that outside of the loop body itself. So we're going to put it up there. Oops. I++, no semicolon. There is not a semicolon at the end of that. Oops. Initialization, condition, increment, and the body. So I prefer a for loop instead of a while loop for this kind of go from 1 to 10 thing. And I think you will too, because notice that it kind of takes out the interesting bit of the loop. Like the real work was I wanted to print I, where all this stuff up here was worrying about how I ranges. Okay? That separation is really nice once you get used to it. It's like I want I to range between 1 to 10, incrementing 1 at a time, and here's how I want to use I with each new value it gets. You see how I'm reading that? That's essentially the beauty of it all. Okay? So, essentially, like, you say only the real work goes in the body of the for loop. Okay? Print I. And this is going to print from 1 to 10. There it goes. So initialization, initialize I to 1, never come back to this line. And then while I is less than or equal to 10, do the body and the increment together. Body, increment, as long as I is less than or equal to 10. Okay? Are there any questions about this for loop? All right. Well, let's walk through it. Yeah. Come on, little screenshot shortcut. Again, it's always initialization, increment, or initialization, condition, body, increment. So I is starting at 1. We ran this line, never come back to it. Then while I is less than or equal to 10, 1 is less than or equal to 10, run the body on it. Print my 1. Make I++ now. Increment it. 2 Is 2 less than or equal to 10? Back to the condition. Yes. Body. Print the 2. Increment. I++. Is 3 less than or equal to 10? Because we come back to the condition. Yes. Run its body then. Print I. I is 3. I++, because we always end with the increment statement before we come back to the condition. Okay? So that's going to eventually get us to what? Print all the way to 10. So I is 10. 10 is less than or equal to 10. We print it. I++ makes it 11. Is 11 less than or equal to 10? Check the condition one last time. It is false. And so we stop our loop. Okay? Loop is done once the condition becomes false, just like a while loop. Okay? So we don't print it even though it becomes 11. Yeah? Any questions about that? Does it make more sense? The same amount of sense? All right, because I have a question for you now. So take, I don't know, 2 minutes this time, help each other, change this code so that it prints not from 1 to 10, but from 20 to -5, decreasing. Okay? So give that a try. What do we think? Question. All right, did we get it?
Yeah, I got it.
Nice. You're getting used to the process then. All right. What did we change? Yeah, you better start I at 20. Good. 20. What else needs to change?
I is equal to 0 or equal to.
Yeah, we want to go downwards. We're moving downwards, so we want this I to keep printing itself as long as it's greater than or equal to -5. Something involving our stopping condition. Good. So I is greater than or equal to -5. We want it to continue printing as long as that's true, but once it gets to -10, we're done. That'll stop it. And then, what else? The last thing.
The increment is I equal to I minus 5.
Very good. Yeah, so this line, which remember what this line was, I++ is equivalent to I equals I plus 1. We want this to decrease by 5 now, so we have to do something like, I don't know, I equals I minus 5. Alternatively, I minus equals 5. That also works. Okay? And then I'll do it. And then the body stays exactly the same because it's just manipulate how I ranges. Manipulate the values that I ranges over. And it's just whatever it is, print it. That's the beauty of a for loop. Worry about the ranging up top, then do stuff with the values that the variable is ranging over in the body. Okay? Any questions about this one? Because I want to tell you something interesting now that only really comes up when we have a for loop. A for loop is slightly different from a while loop in the sense that this variable, this I variable, does not exist outside of the for loop like it did with the while loop. The I variable is going to go away, in fact, when the for loop is over. If you had another I outside, it would get that old value, not like 11 or anything. So that is a weird concept. It's called scoping. Okay, so let's talk about the scope of variables now. That's just a word that means which variables are alive, visible, usable, whatever word you want to use. So, yeah, I think you've probably tried this by now, but inside of loops, conditions, you can have braces, right? Inside of those braces, things can live. You can make variables. Those variables, we haven't thought about it. I haven't told you about it. Maybe you read about it. Those variables are only alive and accessible between its braces, between its enclosing braces. So I can do something silly like this. Brace int I equals 42. Pretend this is like an if statement or something. And then inside of that, I'll have some other, like a loop or another if statement or a for loop. I can make another int I, make it 55. And then there's its enclosing brace. I can, inside of that one again, start another brace, make int j, give it values, do stuff with it. Closing brace, outer closing brace. Let me kind of walk you through how this is going to happen, how this is going to work. You're allowed to make variables with the same names in an inner scope, in an inner brace. It's totally allowed. It's a horrible idea, though, because what it does is it coexists. The closer one takes precedence, and it's going to shadow, we say. It shadows that outer version of the variable. So we're out here, we run this line. All right, cool, I is 42. Then we get to here, and we make a new variable I that holds 55. It's different from this other one out here. We can't even touch this one anymore until this brace is over with, because that I has now shadowed the outer I. Does that make any sense at all? It's a very weird concept. You can get around it by just never using the same variable name again. That's what I encourage you to do, definitely. But that's what's going to happen. You can update this I, be like I++. This will make this one 56, and it will not touch this I, okay? And then once it hits its closing brace, this I no longer exists, which is weird. So if you talked about I here, it would be the 42 again. Isn't that odd? And then j as well will just exist for a short period of time in between those braces, and then it'll go away. There is no j. You can't print j out there. J doesn't exist anymore. It's only alive for the braces that it lives inside of. Okay? It's only alive for that lifetime. It's opening and closing brace. This is its birth. This is its death. Okay? So yeah, just please don't do this, but you can, and now you'll hopefully do it better than you might have otherwise. And the reason I say that is because the for loop makes its own scope. It's essentially this I is being defined inside of the for loop. Even though it's not a brace, you can think about it as this like parenthesis being a brace. If I print I here, I'm going to get a compiler error. Error, I was not declared in this scope. Wow. It's almost like the words I'm teaching you. You know, other people use them too. Isn't that beautiful? So, doesn't exist. It lives for the life of the loop. I's scope is not within there. Okay? So this doesn't work. And you legitimately can do this in C++. You don't even need an if statement. You just make some braces. Braces, braces, braces. Again, bad idea. But here, x equals 42, int x equals 55, int x equals 100. Watch this. I don't even know, man. C out x. Same line, different scope. C out x, C out x, C out x. Can do it down here as well. Can do it down here as well. Can try it out there, but again, it'll be a compiler error because there is no x out here. So we'll deal with that later. These are scopes. This is disgusting, but it's possible. Let me save it. Boop. Compiles. Runs. Alright. This should make sense to us now. This x is 42, so it prints 42. Inner scope. This x shadows the 42x, so it prints 55. Inner scope. This x shadows the other two x's. Print this x as 100. Closing brace kills this x. We're out to this one again. 55. Another closing brace kills this x. We're out to this one. Prints 42. If we go outside of even that one's definition, x no longer exists anywhere at all, so compiler error. X not declared in that scope. So this is possible, and I don't want you to ever do it. Okay? Have a very good reason for it if you do. Any last questions about that before I show you one more thing? Okay. Here is my demo that brings together all that we have learned. So let us lowercase an entire string. I showed you how to capitalize one character of a string. Let's go through an entire string, maybe all caps, and make it lowercase. Let's have the user give us a string in all caps or something. Any string at all. We're fine with it. And then we'll take it, maybe the user types blah, all caps. And what we like to do, remember indices, we like to go through this entire string and lowercase every single character in it. B, L, no matter what the string really was, we'll go through every index no matter what. Even if it was a very long string, we have to figure out how to go through every index, okay? And we can use the size for that, remember, okay? So, yeah, we want to keep on repeatedly changing these indices. And I have to go through every index in this string. I have to go through every character in this string. The terminology is iterating through. To go through something in computer science, we say that we iterate through the indices of this string. We iterate through the characters of this string. Iterate is just a fancy Latin root word that means to go, right? So we're going through this string, essentially. We say that every loop, it iterates. And so that's why we pick the I variable, usually. It's this is my iteration variable. It's going to change with each iteration of the loop. Isn't that neat? So we're going to get used to that word if it's new to us, because I'll say that forever now. That's just the common way to call that. So here's what we're going to do. We are going to visit every index of whatever string we get, call it S, and we're going to call the toLower function on that index. We're going to reset the character at that index. So we're going to make an I variable, have it start at the first index of S, make it 0, and then repeatedly, we're going to loop through every valid index of the string. And we're going to change S at not 0, not 1, but at I to be the lowercase version of itself. And then we'll make I1, because that'll change index 1 next. And we'll make I2. And we'll stop it before it gets to the end. Or before it gets past the end, at least. Does that idea make sense to us? Now we're using an iteration variable, not to print just the number anymore, but to use that number to get at something I care about, to get out pieces of this string now. That's a bit more useful. And remember that we are going to use the toLower function that lives in CC type. just call it on a character, it makes the lowercase version of that character. Okay, so I'll do it with a while loop first, and then I'll show you that it's equivalent to do it with a for loop. So we'll have both. But are there any questions about what I intend to do before I show you the code? Okay, so let's edit a file called, I don't know, lowercase, .cpp. So here we go. I need strings, so I'll include the string library. I need to use two lowers, so I'll include CC type. And now let's do it. See how enter word, string s, get that word, now I have it. And now I want to iterate through every valid index. Iterate through every valid index of s. Replacing each character with its lowercase equivalent. Okay? So the first valid index of s is always 0, assuming that even exists. Maybe the user typed the empty string. We don't know yet. So int I equals 0. That's the first index we care about. So I stands for either iteration index. It's very, very useful. That's why we use I. So that's the first valid index. That's 0. And then I want to keep on iterating while I is a valid index. While I is less than s dot size. This is a Boolean condition that evaluates to true when I is still a valid index. Starts at 0, 1, 2. Remember what size is. Size is how many characters are in this string, right? Size is 4 for blah. The last valid index is 3. You see that? So if I just let I range between 0, 1, 2, all the way to size -1, then I'm good. A fancier way to say that is just don't let I be exactly size. Keep it smaller than size. If it ever gets to be equal to or bigger, we're done. So while I is strictly less than size, that'll make it 0, 1, 2, and 3 in this case, but not 4, because 4 is the size. Does that make sense to us, that condition? That's how we got to do it. And so that will allow I to be a valid index always. And then what we got to do is replace the character at that index, whatever it is. If it's 0, replace the B. If it's 1, replace the L. S at I is whatever it used to be, lowercase, 2 lower. Boop. Boop. Yeah? Am I done yet? Does this work? Or did I forget something? I think I heard it. There you go. Yeah, I is not changing right now. It's always 0. So what's going to happen if I run this program? Enter a word. Blah, all caps. It is repeatedly changing the same character. Index 0 become 2 lower, index 0. Index 0 become 2 lower, index 0. We're never getting through the string. This program's never going to finish. Infinite loop. Control C. I need to make sure that the next time I hit the body, I work on index 1, I++. Then index 2, then index 3, and then eventually the I will get so big that it's not a valid index anymore, and I'm done working on the string. Okay? See out the new S. Blah. Lowercase blah. And this works no matter what. Like, my name. Lowercase my name. It goes through every valid index. 0 is the first one. And then as long as I is less than the size, so there's 4 indices in blah, we want to go between 0, 1, 2, and 3. Never get equal to the size. Okay? Change that index. Make sure we're ready to work on the next index in the next iteration of the loop. Okay? New words, new concepts, but I think we're slowly internalizing it. What questions do we have about this code? Do we see how this is going to operate on index 1 first, index 0 first, excuse me. Then I is now 1, operate on this index, as long as I is less than 4, which is s.size. Okay? I want it to range between 0, 1, 2, and 3. Stay strictly smaller than 4, please. Increment one at a time. Because that's the while loop version. We can very easily translate this to the for loop version. Boop. So let me comment this out so that we don't touch the string anymore in the for loop. So again, it's very quick. Once you've already written the while version, this is the initialization. For int I is 0, I is less than s.size. The condition just comes over. It's in the middle there. And then the increment is, all right, how are we manipulating I plus plus. So this is, in the start of this loop, we're saying exactly what we want to have happen with I. I want I to range between these numbers, these valid indices of s, please. And then the body is just the one thing that actually does the real work. That's the please update that index. Okay? So it's a cleaner little package, maybe. And I think you'll grow to love the for loop if it's still a little confusing to you. And it does the same thing. Okay? Are we good with that? Changing strings by going through every index. I gets to be every index. 0, 1, 2, 3, because we're iterating through all those numbers. All those valid indices of that string. All right. So if we're good, I think I'm ready to release your next lab. So off we go. This will be lab 2, and it's going to be a 2-week lab. So it's not going to be due next Friday. It'll be due the Friday after that, so the 9th. You are welcome. I'll delete that in a second. Whee! So here is your lab. I'll also go to the class server so I can walk you through the starter code. If it wants to give me a terminal prompt. Here we go. Labo2, go into your labs folder. I was doing the same thing for my other CSCI class. Let me delete the lab 2 folder and call it again. Gimme lab 02 at CSCI 40. Copied into our current directory, cd labo2. What's there? These 2 files. Fuzz, biz, baz, and tic-tac-toe. Okay? Got those 2 files. Off we go. So, part 1. I guess I call it part 2. This is FizzBuzz all over again, but fancier. Okay? So, just use the comments to see what needs to happen. It's called Fuzz, biz, baz. I tried to be clever. So, you're going to ask the user for a number with a prompt, of course. And then here's what you do. Here's the new game. It's not 3 and 5, print fizz and buzz. It's if it's divisible by 2, print fuzz. If it's divisible by 3, print biz. If it's divisible by 5, print baz. So it's very similar to FizzBuzz, but different. And then any combination as well. So if it's divisible by 2 and 3, print fuzz biz, because that's the fuzz and that's the biz, right? Kind of self-explanatory. If it's divisible by 2 and 5, print fuzz baz. 3 and 5, biz baz. It's just all of these individual ones combined. If the number is divisible by 2, 3, and 5, so like 30, then you're going to print fuzz biz baz. Okay? Otherwise, you're printing just the number. If none of these are true. It's like 7. You're just going to print 7. Okay? So you're going to have to be very careful about the order of these, aren't you? These conditions. So you'll watch out for that. And then if you finish it early, I can help you simplify this. There is a trick that lets you do this in just 4 if statements. Maybe an extra variable. Just 4. Which is weird. You can think about that maybe once you do it the normal way, the way I taught you. So that is fuzz, biz, baz. Here are some sample runs. 2, 3, 6, 10. 11's a prime number, so nothing goes into it. And then 30. Okay? Any questions about that? It's just fancier fizz buzz. Getting practice with our conditions and ordering of our conditions and our if else's. So that's how you compile and run as usual. And then part 3 is tic-tac-toe. So this will be fun. More if statements. So this program, the user is going to type a tic-tac-toe board to you. They're going to type it in order, okay, from top row to bottom row. So if the user wants to figure out who won, because that's going to be your program, with this board, they're going to give you the board in row order. So they're going to type XOO, OXX, XOX. Does that make sense? It's just in order from top to bottom. That's how the user is going to type the board to get into your program. And you're going to read that board with CN, kind of like how I was doing today with a bunch of CN statements all at once. You're going to get a bunch of character variables. You're going to get 9 characters. They're each going to be X or O. Does that make sense? So you're going to get a board from the user, put them into 9 separate variables or something, and then your job is to determine, based on the board that the user entered, whether there's a winner and who the winner was, if so. So for example, if the user typed this board in, you would have to say that X won the game. Okay? Because you find that they win the diagonal. Everybody knows how to play tic-tac-toe, right? Diagonal, or a row, or a column. I won't be tricking you in any of the test cases. There will only be one winner, if any. So here is some sample runs. Like you type the board, you get that from the user, and then you calculated that X won the game. Or if O wins, you calculate that O wins the game. Otherwise, if nobody won, you should output that it's a tie, right? Because that's possible too in tic-tac-toe. So you're going to get all the board characters and then use a bunch of if statements to see who won, if anybody. So that's tic-tac-toe.cpp, and here's how you do it. Here's my suggestion to you. Call the board characters this, because I've given you some starter code that uses those. And this is what they will represent. B11 will be the very top left, B12, B13. So you're going to get them in order. Get B11, then B12, then B13 from the user, because they're going to type it in this order. And each character will be separated with white space. That's how you type it in if you want to get them all in one line from the user like that. Just a very long CN line that gets B11 through B33. Okay? So make your 9 char variables and get them. And then here's what I'm doing. Here's my sample code for you. I have already checked the rows to see if there's a winner, and you'll use this when you implement the rest. I don't need any else ifs because there's only going to be one winner, if any. So I start this winner variable with a question mark because maybe nobody wins. And then here's how I check if somebody won the game. Okay? And I'm checking the rows for you. I gave this code to you to check the rows for a winner. You'll do the same for the columns and for the diagonals. So if somebody won the game and they won it with this row, here's how you check for that. That means that all of these are equal, right? They were all X or they were all O. This is how you check that. You say, all right, was B11 equal to B12? Because you can only check 2 things at once. And then was B12 also equal to B13? Do you see how that implies they were all equal to each other? That's the condition. If this is true, somebody won the game in the top row. And the winner was, well, we just determined that all of these are the same, so you could say that the winner was B11 or B12, B13, because they're all X's or they're all O's, right? So I just say that the winner was B11, but I could have said either one of these other ones. So that's how you find a winner in the top row. Same for winner in the middle row. Just check if B21 equals B22 and B22 equals B23. That means there was a winner in that row. They were all X's or all O's. And the winner was, well, just pick one of these because they were all supposed to be the same, so the winner was B21. See that? Same for the third one. These are all equal to each other, so B31 was equal to B32, and B32 was equal to B33. The winner, because these are all the same, I'll just say it was B31. Okay? You can have a bunch of these. So it's your job now to check the columns for a winner. winner, and the diagonals. Okay? See if there was a winner. There will only ever be one, so you don't need any else ifs. You can just use a bunch of if statements if you want to. Just keep it like I was doing. And then once you get to the end of the game, I'm trying to get you to use this winner variable. It'll either be set to something other than question mark or the winner, right? Or question mark. Right? So if x1, print the line saying that x won. Similarly for O. If it's a tie, just print a line saying that it's a tie. And I think you can use this winner variable to determine whether or not somebody won or if it was a tie. Yes? If you do the same strategy that I was using. If you continue with that. Okay? So that's a bit more involved. That's why it's the second half of the lab. But are there any questions about it?
Those are like the chart like B11 and B12. It's just for the example, or you want the output like that?
I want you to call your variables these. Call them B11 because you need to get a bunch of X's and O's from the user. 9 of them total.
Okay.
Call the first thing you get from the user because it's going to represent this upper left character. Call that B11 because that's what I'm using to represent that piece of the board. It's a variable name. I want you to use that variable name.
Okay.
Does that make sense?
Yeah.
Yeah. So these are your 9 variables that you'll be using, and here's what they represent on the board. Other questions? All right. So I think that is everything that I wanted to say. You're going to turn in the 2 files that you edited, of course. And you have 2 weeks to do this lab. So I think that's all I wanted to say. I'll stop recording now.